Hello guys, how are you all? I hope you all are doing well and your also study is also going very well. And our today's class is also going to very interesting. But don't believe me. Use the rule of tide. First use, then believe. Okay. And can I start? Okay, I am starting then. And in the very first class, what we studied? We studied about whether a sequence is whether a sequence is bounded or unbounded. Am I clear? Am I right? Yes. And the very next class means in the second class we studied whether a sequence is convergent and divergent. And why we studied? Is there any relationship? Don't go that side. Between this convergent and bounded. If my sequence is bounded, whether it will be convergent or divergent. If it is divergent, then will it be bounded or unbounded? So many questions are coming to my mind. So before going to that, let me say another small things. Suppose this is my sequence. This is my sequence with all terms are A1, A2, A3 up to like this. Can you think? Is it possible that some terms are converging towards A and some terms are converging to B? Then my sequence will be convergent or not? If some terms are converging to be A and another some terms are converging to B, then will my sequence be convergent? No, this is not the case. It is not possible. If it is convergent, it should converge to only one. Means it is the modern era, na? Every person has one wife. It is not like kingdom era. Okay. So my sequence is convergent if and only if it is convergent to only one number. Means my limit of the sequence, and I call this as what I call this A and B as my limit of the sequence. Now, if my limit is convergent, then if my sequence is convergent, the limit of sequence is only 1. Suppose limit I am saying, suppose A is a sequence, its limit is A, and as well as A is a sequence with limit as B. When this is possible? This is possible if and only if my A equal to B. Means what I mean to say, a sequence has only a sequence has only one limit. Okay, it can't have two limit. Then go to our what I told at first. What is there any relationship between convergent, bounded, like this? So I am going to draw a very small diagram, and I am challenging you. You will remember for long. So what we studied? First we studied we have a sequence. Either a sequence is bounded or unbounded. Is it clear? Bounded means it has supremum and infimum. Unbounded means supremum infimum means it has upper bound, lower bound. Unbounded means it either don't have supremum or it may don't have infimum or it may don't have both. Okay. Then bounded. Bounded means suppose my sequence all terms will remain within this bounded. For example, this 1 minus 1, 1 minus 1, this sequence is bounded because its infimum is minus 1 and supremum is 1. Similarly, in the first video, I asked you one question. 1, 1 by 2, 1 by 3, like this. I asked you whether the sequence is bounded or not. The sequence is bounded with supremum as 1 and what is the infimum? Infimum is 0. So both sequences are bounded. But see here, means this sequence is 1 by n. No? And we proved in the last class this sequence is convergent. But this sequence is divergent. We proved in the last class. No? So if my sequence is bounded, there may be two cases arise. It may be convergent or it may be divergent. Understood? Now consider the second case. If my sequence is unbounded. If my sequence is unbounded means one term will lies here, one term will here, one term will here, one term will here. Means how can you convergent? How can you converge to all terms to a single point? Even if the gravitational force also can't attract them. Are you getting? Means if my sequence is unbounded, it will be divergent only. It can't be convergent. Are you thinking it will converge to one point? No, na? So this diagram, is it easy? If you remember this diagram, then you can answer every questions. So if I ask you, if a sequence is convergent, if my sequence is convergent, it is bounded or unbounded? You can directly say if my sequence is convergent, it will be sure bounded. So I can write a point, every convergent sequence is bounded. Understood? See this diagram? See, in the same manner, I can say every unbounded sequence is divergent. Okay? Every unbounded sequence is divergent. Is it clear? The concept of convergent and divergent, bounded and unbounded, and what is the relation between them. And now let me solve some examples. My question is, so that limit n tends to infinity 2n minus 3 divided by n plus 1 equal to how much? Can you say? I will remember your intermediate how you solve this. If you don't remember, then how will you do? You can either take common n from here and n from here. If you take common, then it will be 2 minus 3 by n, and here it will be 1 plus 1 by n. Then n cancel, put n as infinity, it will be 2 minus 0 divided by 1 plus 0, it will be 2. Okay, or you can do another way. If you put infinity, it is coming as infinity by infinity form. Then just differentiate with respect to n. If you differentiate, you will get 2 by 1. So it is 2. Okay, na? But I don't have to find this. I have to prove this. I have to show this limit should be equal to 2. Means I can say this is my an, this is my a. Yesterday we studied, if a sequence is convergent to a, then my mod of an minus a should be less than epsilon, and not for every n, for some n greater than equal to m. What is m? M is a natural number. Yes. So can I write here? Here my an is this one. So I can write 2n minus 3 by n plus 1 minus 2 is less than epsilon. If I can prove this, then I can prove this equal to this limit equal to 2. So now consider this one. This modulus 2n minus 3 divided by n plus 1 minus 2. Okay. And what is epsilon here? Epsilon is any positive real number. It is not valid for all n. It is valid for some n which are greater than equal to m. And m is of course a natural number. So now solve this. What will this? N plus 1, 2n minus 3 minus 2n minus 2 whole modulus. It will like 2n minus 2n cancel, and modulus becomes minus 5 by n plus 1. And we know n plus 1 is greater than n. So can I write 1 by n plus 1 is less than 1 by n? Yes. If I multiply 5, means 5 by n plus 1 is less than 5 by n. So can I write here it is less than 5 by n? If I prove this is less than epsilon, then I can prove this. So I can prove this. So my 5 by n is less than epsilon. When it will be possible? If and only if my 5 by epsilon is less than n. 5 by n is less than epsilon. If and only if my 5 by epsilon is less than n. Understood, na? Now let us see. We assume epsilon. Epsilon is any positive real number. We have to find the value of m. Okay. Suppose I am giving you one equation with two variables like this. X plus y equal to 1. Can you solve this? Can you solve this equation? If you solve, then you might be God. but you can't solve this. There's only one approach. You have to express one in terms of another. How? You can write y as 1 minus x. Similarly, here my epsilon is unknown to me and m is also unknown to me. Both epsilon and m are unknown to me. So what is the only approach? I have to express one in terms of another. Like here, here I express y in terms of x. Understood? So here I can write. So I have to choose m. So what will be my m? I have to choose such m, which is of course a natural number, such that my phi by epsilon is less than m. My phi by epsilon is less than m. Okay, and now we know this n is greater than equal to m. This n is greater than equal to m. So can I write? And also m is greater than phi by epsilon. I can write phi by epsilon is less than m is less than equal to n. If this is, then can I write phi by epsilon is less than n? If phi by epsilon less than n, then I can write phi by n is less than epsilon. See here, if phi by n is less than epsilon, this my whole modulus will be less than epsilon, and this is proof. So my limit of this sequence will be 2. Understood? Before going to next example, I am thinking to give some example based on some numerical value of epsilon and m. Suppose I will say in this problem my solution will be x comma 1 minus x. Some people will look like this. But if I will say if my x is 0, then my solution will be 0 comma 1. Then people will say, this is the right. It's not for all I am saying. For example, if x is 1, then my solution will be 1, 0. Like this means if you take numerical value, then our brain will accept quite faster. So here I am assuming, suppose I am giving you epsilon. Suppose my epsilon is 0.1. You have to find what is the value of m. See here. Suppose my epsilon is 0.1. So what is my m? M should be less than 5 by, m should be greater than 5 by epsilon. So what will be 5 by epsilon? It is equal to 5 by 0.1. It is equal to 5. And my m should be greater than 50. That means my m equal to 51. Means here we draw the sequence na a1, a2 like this. Suppose here is a51, a52 like this. Means after all n greater than equal to m, means here after all n greater than equal to 51, means from here to here all are converging to 2 except this. Understood? In the same fashion, if I give you my epsilon is, if I give you my epsilon is 0.2, what will be my m? What will be my m? I know phi by epsilon. What will be phi by epsilon? Phi by 0.2. It is equal to 25. It should be less than m. So my m is 26. Means from 26th term onwards, my whole sequence will converge to 2. Understood? Now let's consider another example. So that limit n tends to infinity, square root of n plus 1 minus n equal to 0. So that this is equal to this. Means what is my n here? This is my n, this is my a. That means I have to show, what is I have to show? Mod of n minus a is less than epsilon for all n greater than equal to m. That means here my root n plus 1 minus root n should be less than epsilon for all n greater than equal to m. And what is epsilon? Epsilon is any positive real number. Now consider this modulus. And how will you solve this type of problem? Do you remember? When this type of problem is there, we have to multiply the conjugate both in numerator and denominator. Suppose a plus b is my expression. What is its conjugate? Is a minus b. It's its conjugate. If A minus B is the expression, its conjugate is A plus B. So just multiply its conjugate with both numerator and denominator. Here denominator is 1. Can I write 1? Yes. So multiply. Multiply both in numerator and denominator. Here see, A minus B into A plus B means A square minus B square. Put the formula, you will get what you will get, 1 by root n plus 1 plus root n. Can I write n plus 1 is greater than n? So square root of n plus 1 is greater than square root of n. If I will add root n, it will be 2 root n. If I will do 1 by square root of root n plus root n plus 1, it will be less than 1 by 2 root n. Understood? So this will be less than 1 by 2 root n. And I have to show that this should be less than epsilon. Yes, if this is less than epsilon, then this whole modulus will be less than epsilon. So when it is possible, 1 by root n is less than epsilon if and only if my 1 by 4 epsilon square is less than n. Yes, so I have to choose now m. So what will I choose m? I will choose m as, choose m, what is m? M is any natural number such that 1 by 4 epsilon square is less than m. If, and we know n is greater than equal to m, I can write here. Okay, so here it will be 1 by 4 epsilon square is less than n, means 1 by 2 root n is less than epsilon. So it proved, if this is less than epsilon, this whole modulus is less than epsilon. Square root of root n plus 1 minus root n is less than epsilon. Now of course it is for n greater than equal to m. Proved. Now write some point in the form of notes. Note 1. If limit n tends to infinity, an equal to a, that implies limit n tends to infinity mod an equal to mod n. I can prove this for you only in just in 2-3 lines. See here, limit n tends, this is given, that means I can write now mod of an minus a is less than epsilon. And what I have to show? I have to show mod of mod n minus mod a is less than epsilon. Do you remember the first class? I wrote mod of x minus y is greater than equal to mod x minus mod of mod y. Can I replace this x by an and y by a? Just replace. I am writing this at first. So mod of mod n minus mod of mod a is less than equal to mod of an minus a. And we know this is less than epsilon given. So this is less than epsilon. So this is proved. Understood? But the converse is not true. If it is given, you can say this is correct. Okay. For example, consider the sequence 1 minus 1, 1 minus 1 like this. Take the mod. Means 1, 1, 1, 1 like this. This is my an. This is my mod n. And we know this sequence is convergent to 1 because all terms are 1. But this sequence is divergent. Okay. So this converse is not true. Now consider the second point. Second notes. If limit n tends to infinity mod an equal to 0, then limit n tends to infinity an equal to 0. In the same fashion you can also prove. See here. That means it is given mod of mod an minus 0 is less than epsilon. I can write mod of mod an less than epsilon. Means how many times I will write mod, it will become same. I can write 1 also. Mod of an less than epsilon. I can write this mod of an minus 0 is less than epsilon. Which prove this one. Understood? Now the third notes I am going to write. but I'm not going to prove this one. If you understand all, if you understand what I explained today, then you can do like that. Limit n tends to infinity, b to the power n equal to 0 for mod b less than 1. Just I am giving you example. I will try to explain you through example. Suppose mod b is less than 1, means it will lies between -1 to 1. Take any number between -1 to 1, suppose 0.2, or take 1 by 2 like this. If you take 1 by 2, it will like 1 by 2 to the power n, means 1 by infinity equal to 0. Okay, so I told you just by example. You can prove it by taking epsilon, and here you have to take logarithmic, and if you understood it, then you can do also. It is not a big problem, but if I will solve it, the video will be very lengthy. So this is all for today. If you want to practice more and if you want to know more, you can solve some problems of the book, or you can solve the examples also. So for today, goodbye, tata.